Hello and welcome to my YouTube channel. Today in this video, we are going to see how to program the UART module of TIVA C board and use the switches of the TIVA C board to print messages on the console of Tera Term software. So without any delay, let's start the video. So first of all, let us briefly talk about the UART and the features of UART in the TIVA C board. UART stands for Universal Asynchronous Receiver and Transmitter, and the features of the UART in TIVA C board includes that it has got 8 UART modules. So basically the microcontroller TM4C123GH6PM is the microcontroller which is used here in our project, and it contains 8 UART modules. Therefore we can connect 8 different UART modules or devices with the TIVA C board. Second, we can program the baud rate. Baud rate here we can say the message rate or data rate, not the data rate precisely but message rate. So we can program the baud rate of the UART and we can reach up to maximum 10 Mbps for communication. The UART module uses asynchronous communication and we can configure the start, stop and parity bit. And the other programmable features include the word length. So we can configure the word length to be 5-bit, 6-bit, 7-bit or 8-bit. So each word in the message can be configured either for 5-bit length, 6-bit long, 7-bit long or 8-bit long. Similarly, we can configure the parity to be even, odd or no parity. This is used for the error-free communication or detection of the errors in the message. Last, we can configure the stop bit to be 1 or 2-bit. If you are using very high speed communication, prefer to go for 2-bit for stop bits. And if you are using low communication rate, then in that case you can go for 1 stop bit. Suppose if you are getting an error or if you are getting an unsynchronized messages, then in that case you can play with this stop bits. Now coming to the physical connection, suppose you have 2 UART modules, then in that case the transmitter pin of the first UART module should be connected to the receiver pin of the second UART module, and similarly the receiver pin of the first UART module should be connected to the transmitter pin of the second UART module. So therefore UART communication is a 2-pin communication. So we need only 2 pins for the communication using UART modules. Now the steps to use the UART module in the TIVA C board. In our program we are going to use UART module 0. So first of all we will have to provide the system clock or clock gating to the UART module 0, and to know the pins which are connected to the UART module 0 we can refer to the data sheet of TM4C123GH6PM microcontroller. Here in table number 14.1 you will get all the details related to the pins and signals available for UART modules. Here we are using UART 0, therefore we can see UART 0 receiver pin is connected to port A0. So the port A0th pin is connected to UART module 0's receiver pin. Physically this pin is the pin number 17. Similarly UART 0 transmitter pin or UART 0 TX is connected to port A's first pin, or we can say PA1. Physically this pin is pin number 18. And similarly you can go down and check all the pins which are connected to the different UART modules. So like I said, we have UART 0 to UART 7 and you have to configure the port and pins accordingly. Here in our case we are using UART 0. So we'll be working with port A and we will be configuring port A0 and port A 1 pin. Now, next we will have to provide clock to GPIO port A. We know the peripherals are by default configured as disabled to save the power. To enable any peripheral, we will have to first provide the system clock, and for that, because we are going to use port A, we will be providing the system clock to the port A module. Then we will have to provide system clock to GPIO port F module because we are going to use the switches of the TIVA C board. And if you recall, the switches of the TIVA C board are connected to PF0 and PF4. Okay, so PF0 and PF4 will be used here. Therefore, we will have to provide the system clock gating to GPIO port F module. After that, we will have to configure the pins of GPIO A as transmitter and receiver. Next, we will have to configure the UART module's baud rate, word length, stop bit and parity bits. After that, we'll be polling or reading the state of switches, and accordingly we will be printing the message on the console of Tera Term software. This is all the steps required to program the UART module and print messages on the console of Tera Term. So let us write the program on Code Composer Studio. For that, let me open the Code Composer Studio. Click launch. It will take maybe a second or two to open the Code Composer Studio. So here we can see the Code Composer Studio, and we can start a new project by clicking this button, Start New Project, or going to File, New and CCS Project. In these two ways, we can start a new project for the TIVA C board or microcontrollers from Texas Instruments. We can click on Start New Project. If you are new, then let me show again how to configure the project. First of all, we will have to set the target. In this case, it is TM4C123GH6PM microcontroller. In the right, you can see the list. So click on the TIVA TM4C123GH6PM microcontroller. After that, to communicate between the microcontroller and the PC, we will have to configure the debug or debugger. So we will have to use Stellaris in-circuit debug interface, also known as Stellaris ICDI. Select that. Give a name to the project. So let me give a name, UART _ switch _ programming. So you can give any name according to your choice. Then click on the empty project with main.c and click finish. This will bring you to a new window with the basic program having the main and return 0. Apart from that, in the left, you can see the project explorer window, and all the relevant files have been added by the Code Composer Studio. Apart from that, we will have to add few more folders and files. Let me show you how. So first, right click on the project, go down to the properties, and then click on the include options, and then click on this plus button, add, and browse. We are going to add the TivaWare, which is located inside the C folder. If you have not installed the TivaWare, then please refer to the first video of this playlist where I have shown how to add the TivaWare in our computer. So generally the TivaWare is directly installed in the C folder, and then if you go down TI folder, and here the latest TivaWare version is TivaWare C series 2.2.0.295. I will open this folder and click OK. So we have added the folder which contain all the relevant files and drivers. Second, we will have to add a file. For that, right click on the project, click on add files, and we will have to add the driver library file for the TivaWare. So open the TI folder, go to TivaWare C series 2.2.0.295, open the driver lib folder. Inside that, open the CCS folder. This is for Code Composer Studio. Click on the CCS and then click on debug and select the driverlib.lib file. Open that. You will get an option whether you want to just link the files or copy the file to the main project. I prefer to copy the file to the main project folder. Click OK. So this will include the driverlib.lib file in our project. After this, let us just compile the project and see if there is any error. So here on the right side bottom, you can see there is no such errors or problems. So we can continue with the coding. Let me just directly put the code here and explain the code one by one so that we can save time from typing. First of all, we have included the standard header files. First two are for standard integers and standard bool.h. Then we have included the header files for hardware memory map, hardware types, and hardware GPIO.h. Then we have included driver library files for sysctl. Sysctl is used to provide the clocks to the peripherals, or we can say to enable the peripherals. This file will provide the relevant functions and folders. Second, we have included the GPIO.h. GPIO.h will provide all the relevant functions to configure the GPIO pins and ports. Then we have configured the GPIO pin map, GPIO, not the GPIO pin map, rather pin map. Pin map will provide all the list of pins which are available in the microcontroller. Then we have included the UART.h. This will help us to configure all the UART relevant features. Then after that, we have defined some variables for the UART and GPIO ports and pins. Since we are using UART 0 base, I have defined a variable UART base which will be used for UART 0 base. Second, for the port F base, we have defined a variable GPIO port F. Then for the pin 4 and pin 0 of the GPIO, this 4 and pin 0 are for the port F pin number 4 and port F pin number 0. Port F's pin number 0 is connected to the switch 2 of the TIVA C board. Port F pin 4 is connected to the switch 1 of the TIVA C board. Then to handle the key bouncing issue related with the switches, we have defined a variable which will handle the delay, or which can be used to change the delay to handle the debouncing. Initially we have used a value 50. This can be changed according to the functionalities of the features of the switches. Now coming to the main program. In the main program, we have initialized two variables which will store the status of the switches. So we have initialized the switch state 0 and switch state 2 also as 0. So these two are initialized to 0. This will become 1 when the switch will be pressed. Now, then after that, we have configured the system clock. Let me just comment it. So we have configured the system clock, or we can say this clock is basically microcontrollers clock. Okay, so we have used this function. This function is available inside the sysctl.c file. So let me show you how to use these functions. Right click on the project, go to add files, and because we are using 3 peripherals, we are going to use 3 header C files: gpio.c, which will provide the details related to GPIO, sysctl.c, and then UART.c. Include all these 3, copy this to the main project folder, and here first of all we are using sysctl clock set. For that, you can double click on the sysctl.c. In the outline window, if you are new, then you can go to view and click outline window, and this will open the outline window on the right side. And here it shows all the list of functions which are available with the sysctl.c file. So first of all, we are using sysctl clock set, and you can see here in the list, you can go to sysctl clock set. Here this function, and you can read all the relevant details related to this function. This sets the clock of the device. Here the device stands for the microcontroller. So first of all, we have configured the sysctl clock set for the microcontroller. Then after that, we have created a function to initialize the UART. We will see what we have defined inside this function later. Third, we have enabled and configured the port F peripheral and its pins for the functionalities of the switch. So first function is sysctl peripheral enable, and this function is inside the sysctl.c file, sysctl peripheral enable. So you go down and check sysctl peripheral enable. Okay, so this function is used to enable the peripherals, and for that we have to provide the argument related to the peripheral, and here it shows the list of peripherals that can be enabled using this function. So first thing, we will have to enable the peripheral. For that, we have used sysctl peripheral enable, and we are enabling the GPIO F peripheral. If you want to know the list of arguments, you can take it from here. So we have used sysctl peripheral GPIO F. Second, we have to unlock the GPIO pin. This is basically used for the PF0. I have shown in the previous videos why we are unlocking the pin, because PF0 is basically locked by the microcontroller providers, and if you want to use the features in GPIO port F0, then in that case you will have to first unlock it. For unlocking the GPIO, we have to use the function from gpio.c, and you have to use GPIO unlock pin function. And if you want to read the details, you can go up. It unlocks the GPIO pin which has been previously logged. By default, PF0 is logged, and PF0 is connected to the switch number 2. It requires two arguments. First is the port to which the pin is to be unlocked, and the second is the pin which is to be unlocked. Okay, so the port is port F base, and the switch is switch 2 pin, which we have declared or defined as GPIO pin 0, which is port F0. So this is port F0 we are focusing here. We are focusing on PF4, which is basically switch number 1 or switch 1, and this is switch 2 of the microcontroller board. Now, then after that, unlocking, we have to configure the GPIO pins as input pins because it is going to use the functionalities of the switch, and switches are generally input. So for that we can use again the GPIO.c file, and to use the GPIO pin type GPIO input, we have to go up, use this function GPIO pin type GPIO input. It requires two arguments. First argument is the port and the second is the pin number. You can read all the relevant details from the file. Okay, so this is used to configure the pins for use as GPIO inputs. Because switches are inputs, we are using this function. Then after that, the arguments have been passed. So GPIO port F base, and then pin number 1 and pin number 2. GPIO port base is defined as GPIO port F base. Okay. Now after that, we have to configure the pins for pull up or pull down. For that we have to use this function GPIO pad config set. Again, it is available in the GPIO.c file. For that you can use GPIO pad config. You can scroll down. Let me check GPIO pad config. So I am missing something here. GPIO pad config set. This function is to be used, and it requires 4 arguments. First is the port. Second is about the pins that has to be used. Then the strength. Strength here defines the current that you want to allow from the pin. Whether you want to allow 2 milliampere, 4 milliampere, 8 milliampere, 10 milliampere or 12 milliampere, you have to set this variable accordingly. So strength represents the amount of current that you want to allow. And the last one is the pin type. Pin type arguments will allow you to configure the pin as standard pin, pin with pull up, the pin with pull down configuration, and pin for analog, wake up, high, low, so on. Then after that, the configuration of our port F and all the relevant features have been completed. After that, we will read the state of the switch. For reading the state of the switch, we will have to use GPIO pin read function. Okay. Again, this function is available inside the GPIO.c GPIO pin read function. Okay. So it is available here, GPIO pin read. And this function requires 2 arguments. First is the port detail and the second is the pins. If you want to read the details, again you can go up and read all the details related to this function. And here we can see we have provided the port base. Here the port base is GPIO port F base, and we have configured the pin number 1 and pin number 2, and these two switches will be read and their state will be stored in these two variables. And accordingly, if switch 1 is pressed, in that case we will print the message using this function. I have discussed about this function in the previous video. You can refer to the previous video for further details. And we have used a function delay ms to handle the debouncing issues. We will have to define this function and this UART init function. I will show you how I have defined that. Similarly, the same feature switch 1 will be copied and pasted for switch number 2. So if the switch is 2, if switch 2 is pressed, in that case we'll take a small delay and then read the status of the switch and print the message on the console. Now to the UART initialization. So for that we have created a function UART init. It will return nothing, therefore it is void. Now first of all we will have to provide clock to the UART 0. For that we know we have to use sysctl peripheral enable function, just like that we have used here in the case of GPIO port F. Similarly, you will have to enable the clock for GPIO port A. Now to configure the GPIO port A's pins to support UART communication, we will have to configure the GPIO pin, and this is available in the gpio.c file. Okay, let me show you the function. Again, you can take the help of outline window, and GPIO pin configure is provided here. GPIO pin configure. Okay, this function configures the alternate function of a GPIO pin. What it means? It means the GPIO pin can be configured for different functionalities apart from normal reading and write, making it high or low. So the functionalities like ADC, PWM, timers, UART, CAN, and so on. So the GPIO pins can be configured for any such functionalities. If you are going to configure the pin for any such functionality, then you will have to use alternate function on the GPIO pin. For that, we will have to use this function GPIO pin configure. So we have configured the pin of port A0 as RX. If you are not familiar with how to use these, how to get these values, then you can just use autofill function. Just type GPIO underscore control space, and then you can see GPIO port underscore pin A PA. Okay, it is not showing the list. Let me just comment it and just compile it for once. After compilation, okay, there is no such error. Okay, what I can do now, I can just check if I am able to get or autofill the variable. So GPIO underscore PA 0 U0 RX. Okay, that is U0 is standing for UART 0's receiver pin. So we have configured GPIO port A 0th pin as UART 0's receiver pin. Similarly, GPIO port A pin number 1 is configured as UART 0 transmitter pin. Why we have done this? Because GPIO port A pin 0 and pin 1 are connected to UART 0's receiver and transmitter, that I have shown in the data sheet also. Now, then after that we have to configure the pins to work as UART. Again, for that, if you are interested to find the function, you can open UART.c and you can check here UART, come down, UART pin type. So UART come down, UART pin type. Sometimes it takes some time to find the correct function. UART because this is GPIO related function, we have to open the GPIO pin type. Okay, GPIO pin type UART. So this function actually configures the GPIO pins to work as UART. You can read here, it configures the pins for use by UART peripheral. It requires two arguments. First is the port and then the pins of the ports which will be used for UART functionalities. So we will have to pass two arguments in this function, and we can see here the first argument is port A base and the second argument is the pin number 0 of pin port A0 and then pin 1 for port A1. With these three lines, we have configured the GPIO port A's pins to be used as receiver and transmitter. Then the last configuration for the UART is to provide the word length, stop bit size, parity bits, the data rate, and so on. For that, we have to use UART config set clock. So if you want to see the function, you go to UART.c and you can use the function UART config. Okay, so UART configuration related. So UART config set exp clock. You come up and read about this. This sets the configuration of UART. What are the configurations related arguments? First is the base address, then the clock, then the baud rate, and then we have to use 4 variables to configure this particular argument. So what are the 4 variables? First is the word length, then whether you want to configure the parity even or odd, then what is the size of the stop bit, whether it is 1 bit or 2 bit, so on. So here I have used UART base. UART base is UART 0. Then this function is used to get the clock frequency of the microcontroller. This will be provided by the sysctl.c folder. Sysctl.c file. Here this argument is for the baud rate. Then inside this bracket we have configured 3 things. One is the word length. The word length is 8 bit, stop bit, and parity bit. If you want to see the details of these functions or how to get to these functions, you can just visit the previous video. I have explained each and every line in a very detailed manner in the previous video. That's why I am just escaping this part. Then after that, to print the message, we will use this function While the message is not completed, just use UART char put function. UART base is our UART 0 and pointer to the message, and increment the message till the message is not complete. And this character shows if the message is complete or not. And remember, there is no string variable, string data type in C, therefore we have to use character only, and we can use this kind of approach to get the features of string. Last but not least, the function related to delay. This function is used to handle the key bouncing related issues. So delay ms, and we can provide the variable in milliseconds, and here you can see we have already declared a variable and a value 50. By default this value will be passed here. So uint delay, we have created a variable. For delay is equal to system clock get, this is the system clock frequency, divided by 3000 into milliseconds. So the delay starting from this range till the delay is greater than 0, decrement the delay. Okay, and this will handle the debouncing related issues. And we can see when we are reading the switch, we are using this function here, delay ms. So delay debounce delay ms, this value will be passed in the delay ms function. So this was all about the programming part. So let me just compile the program, upload the program by using Flash. Click on the Flash button, this will upload the program. Once the program is uploaded, we will open the Tera Term software. And in the Tera Term app, we can go to serial, configure the serial communication. If you have connected the board or TIVA C board to the microcontroller, you will be able to see Stellaris virtual serial port comb. So click on that and click OK. Now let me open the camera so that you can see how the board is going to work. I believe now you can see on the top right the TIVA C board, and in the Tera Term, let us set up the Tera Term. Go to setup, serial, and here we have to provide the baud rate. If the baud rate is not matched in the transmitter and receiver section, then you will get garbage values. So we have configured the data word length to be 8-bit. There is no parity bit. We have used only one stop bit. So click new setting. And right now you can see there is no message getting printed. Let me print the message by pressing the switch. So switch 1 pressed, switch 2 pressed, switch 1 pressed, switch 2 pressed, switch 1 1 1, switch 2 2 2. Okay, so in this way we can use switches to pass some messages to the computer using UART module. With this, I would like to end the video. I believe the video is a bit lengthy and I was a bit fast in this video. If you have any doubt or suggestions, please share your doubts and suggestions in the comment section. If you have not subscribed the channel, then please subscribe the channel and click the bell icon so that you can get the notifications of the videos when I load a new video. Thank you and have a nice day.